Hello, my name is Gabriel, and today I'd like to show you how you can use BATS to test your pipeline's custom logic on Azure. BATS is BATS automated testing framework, and basically you can find all about it from its official web pages. There is a wiki page that will lead you to official documentation, and basically that's all that you need to know to start. There's also a couple of extensions that are very important when you use BATS, and one that I find basically essential is BATS assertions, which allow you to use brittle assertions in your test. But all in all, BATS is all about testing shell scripts. So if your Azure pipelines, if you write them and if you use script or bash steps, then, well, you basically develop some custom logics in your pipelines, and then if you do it, it makes sense that you also test it. So I will show you how to do it, but in order to achieve that objective, we need to go through the basic of BATS first. So I have a couple of examples for you, and let's get started. We start with installation. As you can see, I'm using IntelliJ, but feel free to use any other IDE that you prefer. Basically, the examples that I'm using here today, you can find on my GitHub repository. So if you want to follow my steps, you can do so. The repository is in here. Okay. So we start with installation of BATS. You can do it on Linux, you can do it on whatever else you're using. I'm using Windows 10, and I'm pretty sure that most of you will have it too. So we can install BATS by cloning these two repositories and then calling the install script. I put it into a script so that we can do something like that. And then after the installation is done, I can reinstall that again. This is very handy if you want to use it in CI/CD systems, ability to reinstall your BATS framework on the agent where your pipeline or tests are run. When install is complete, then you can check the version. And if the response here is successful, that means that you installed BATS just fine, which is great. Okay, so we covered the installation, which you can deal with that script. Now, in order to write some tests, we need some script to test, and we'll start with something like that. That script goes to this well-known test page. And what it does, it basically retrieves a JSON object that describes the status of a task or a to-do. And as you can see, this to-do is not completed. So we'll get it. Then we'll parse the response. I'll show you what it does exactly. It holds the response, but it's a one-liner, and we want to extract this completed field value from it. And for that, we'll use Oak. Here we're not using any JQ or any other helpers. We are just using bash. Well, Oak, we can assume it's basically pre-installed in almost every Linux box. Okay, so when you do that, we are getting as a result the value of this completed field. Then we take this and save a status. And now if the status is false, then we save it to a file .txt. So we should have false there. And if not, then we exit one and we display that the status is not what we expect, because we expect a non-completed task. Okay, well, that's quite simple. We can run it. And we can check that file.txt contains false. It's not a very complicated script, but this is how people mostly start with it. So they write some kind of automation and that's it, right? It's not perfect for testing, but we'll get to that. And now it's interesting and good object for test because first of all, it calls an external service. So there is an external dependency. Then it does some operation on your local drive. It saves the status to a file. And then we have to pass through the script. So we have two alternatives. So it's a good object to test because we need to test all of those stuff. Okay, so let's try to write the first batch test because we have it already installed. How does it look like? Well, in the simplest form, this script looks like this. There's a convention that tells you that if you have a script called script, for instance, then the test should reside in a file with the same name, but with a batch extension. And this is what you can see in here. We have script sh, and then we have script batch. What we need to do is we need to load the modules that we are going to use. And in our case, we are loading the batch core module and batch assertions. The load is an internal batch command that allows you to share some common code. If you go into what's that, that's basically sourcing files. And then when we write test and we annotate the function with test annotation, then what follows is the name of the test or the function and the body of the test. And the body of the test is very important because it has some specific design. First of all, whatever we test, whether it's a script or a piece of code, it should be preceded with a run statement. Run statement works this way that it executes the piece of code that we provide in here, and it will always exit to 0, meaning that if this piece of code throws error, then our test won't break, won't stop, nothing will get, we won't exit from it. This error code will be caught and made available in special variables, status in this case. And now the test works this way that we should have at least one run statement, and then every statement basically batch expects to be successful. So basically every line should exit with a 0 status code, and you can treat every line as an assertion too. So in order for a test to pass, all of those lines need to exit with 0, basically, in Bash world. Those special variables, there is a few of them. Status is one, which holds the status of this piece of code, the exit status. We also have output, which basically holds the output of recently run statement. And there's also lines, which is an array, and you can access via this lines array variable particular line of the output, and we'll use all of them throughout this video. Now, what's important is that you can have multiple run statements in your test, but each one will override the last one, because the assertions that you can see in here will be, let's say, evaluating those special variables for the recently run statement. Okay, so this status is read from here, but this output is not read from here, but it's read from here, right? Okay, so it's important to understand that our assertions refer to recently run statement. Okay, now how do we run tests? In the simplest form, we simply run batch command on the batch tests file. And as you can see, the test is a pass. You can also run those tests with --tap, because batch is based on test anything protocol. It can print test results in such a way that tap consumers can read it. So tap is basically a protocol which defines how, in a text way, in a textual way, how should we print the test results so that consumers of this protocol can understand it, and that this is language agnostic. So basically, it does not depend on which language you use. The communication in this protocol happens by text format. Okay, but it's just an interesting thing. This is our first test. What it does is we run the entire script, and our assertions are, well, we expect the script not to fail, so to pass, and then we expect that the script will leave the result on our drive, and this result is file text containing false, right? So exactly what I show you in here. That's it. So our test, then it's a pass. Okay, but there are a few problems with the script that we are having here. First of all, it's not really good for tests, and especially for unit testing, because it's just one simple logic and it's difficult to control. For instance, also this alternative pass, because well, there are no functions here. We didn't divide this into functions. There are no parameters that we can call. So what we are going to do, we are going to refactor this script into something that is easier to test. So we'll basically split all of it into smaller, easier to test functions. We add some parameterization and a few other things. Now, after those refactors, the script can look like this. I made it wider so you can compare the initial version with the refactored version. Hopefully you can see all of it right now. I think you can. And as you can see, I separated the logic of this script into functions. So there is one function that's responsible for this piece. So basically getting the JSON object of a to-do and saving that to a status variable. In Bash, all variables have global scope. So if I do it, then the next function will be able to read this variable. And then we have save response function, which is basically responsible for this piece of code, right? So the logic is now split into two functions, and they also accept parameters. So it will make it easier to be tested. And these parameters have local scope, not global one, which we note like this in Bash. And there is one more hack that I used from the article on bots, which you can find on my Medium article. There's a source to that great article. We are adding additional function that basically executes this script, right? So it runs get task with a parameter and save response with the parameters. So basically executes the entire flow from here. And this piece of code controls when this script should be executed. So if I now go here and I do something like this, then, well, there's some typo, I guess. Yeah, I didn't use parameters, but we'll get to this. Basically, when I run my script like this function will get executed. And this condition here says execute my script every time that somebody calls it, except for sourcing. Okay, so when I do like that, then my script is not executed. We are not here because this is not true. So if I source my script, then I will only make available those functions in the context of where the source operation happened, but the script won't get executed. And this is good for testing, and I'll show you why. Okay. Now with those refactors, it's definitely easier to write any kind of test, but we should also learn how do we execute that. As you can see, we accept now one parameter and second. The first one is task ID, so it should be 1, and the second is the file name to save, and we use the file name. Okay, and we get exactly the same behavior. All right, so I said it makes it easier to test. So how would the test look like for our change script? Now, I didn't really change too much in that test case, because after it's changed, we should also make sure that tests pass. as you can see, test passes. The only thing I did, I parameterized the script. So in the script sh here in the call, as you can see, we're taking those parameters from variables. So I made just a little refactoring here. Now, this test is really, I think, an end-to-end test because we are using the real service and then we are using all the functions here, right? So we are using the entire logic and we depend on real services. For me, it's an end-to-end test, even if you tend to disagree with it. Okay, so what would be the next step? Now we've factored our script for testability. We have one test. As I said, we did it because we want to write unit tests. So let's write some unit tests. The script won't really change. So I will move it to that window so you can have a look at it all times. And we'll only work with tests. So here are the tests that I added. So that one remains the same, but here I added 2 unit tests. And now you should be able to see the difference. What I'm doing, I'm sourcing the script. Sourcing makes it so that I can use the functions from here individually, right? It's like loading a module in Java or .NET. Now, if I write get task, you know, this function is available. It will fail because I didn't give it the parameter. I could give it the proper parameter and it will work. So this is what's happening also in the tests. I'm sourcing the script, I'm making the functions, individual functions of the script available for tests, and then I'm running save response function. So I'm running this because it's easier to test. I'm giving it the file name and the states. Oh, okay, I know what happened. Well, when I gave it true, then we are in here and it exits if 1. That's why my terminal disappeared. So maybe we'll use false here. So in this function, we have 2 alternative paths, one and it depends on status. So on this parameter, if I put false, I'm in here, so I'm writing something to a file. If I'm here, then I'm printing something to the output and I'm exiting with 1. So I will show you this test logic. I just sourced the script. Well, I need to source it again actually because I exited. Now I'm doing that. Something is printed. And when I do cut, the status of the tutu is written to a file. Okay, so as you can see, my only assertion for that test is if the output of the file is okay. So the test is called save response, save status to file on false. Okay, so I tested that piece of a function. Now I can write the test that goes through the alternative path and basically just accepts true here and then checks that the output is 0. And these are already unit tests for our function. You also can notice that I'm using here hooks. So as any other testing framework, but also offers you pre-test and post-test hooks, which are called here setup and teardown. There exists also setup file and teardown file global hooks. So a hook that is run before all the tests in the file and after all the tests in the file. And what I'm doing is before each test, I'm making sure that the file is empty. And then after the test, I'm removing that file. Okay, so that's how you can use those hooks. And now I need to make sure that my test actually passed. And I do pass indeed, as you can see, all of them, 1 and 2 unit tests are a pass. So we should move forward. And we'll talk about assertions, because the assertions that I'm making right now are simply pieces of code that return 0, but the buts assert module allows us to write pretty assertions similar to the ones that you have available in any other XUnit test framework or test library. So how would our test look like together with assertions? So here we have assertions. As you can see now, and maybe I'll make that for comparison, we have changed, for instance, comparison of the output to built-in asserts from that module. So assert output checks if the output exactly matches the given phrase. So this is equal to that. Assert output also accepts parameters, so you can check for partial match, which is shown in here. So this test actually covers a bit more than this one. And we also have the negation of assert output, which is refute output. And refute output basically will be true if the condition is false. So basically it's a reversion of assert output. It's like not assert output. So these are some basic assertions that we are using. So we also have assertions to check whether the piece of code running here was a success. So this basically corresponds to that. And already with those assertions, you can be pretty productive. As you can see, I have also parameterized this setup and tear down piece, because basically here we have something that we can put into a variable. So I'm putting that into global variable, and then I'm using that across those hooks and tests themselves, as you can see, because this is global. And also I have moved this repetitive line to a hook here that runs before every test. And that's it. So let's just execute those tests and prove that it all works fine, but this time we'll use a wildcard. You can also run tests from multiple files like this, and that's fine, right? Everything is a pass. So what's the next step? Well, if you look closer at our script, then you can see that this function is easy to test, write unit tests for it, because we have just two alternative paths and we don't depend on anything weird. However, if you want to write unit tests for getTask function, we have a problem, because it depends on an external service. And what we do when we have something like this, well, we write stubs or mocks so that we can test the logic, the behavior of this function in isolation, so independently from an external service. So we need to mock. And how do we mock in buts? That's a good question. Well, basically we are doing this by exporting functions. So I will show you how. Now, in order to show you the mocking, we'll assume that we are writing a test case for this function. The test case here could be basically that when you provide get task ID 1, then what we should have in status should be false, right? So here we should have false if the task ID is 1. If task ID, for instance, is not 1, then, well, we can create some test data. But in order not to be dependent on external service, then we need something. Well, the mock needs to return certain data, and we can take data from this call. So the mock needs to return that object, and basically for that object we expect status to be set to false. So we save it to a data.json file in here as a one-liner, because basically if you do it like this, then I can just remind you that it's a one-liner. Okay, so we save it to a file. We also save a negative case for that test, which basically differs with completed status set to true, right? So we have test data. Now we are ready to mock. And now mocking looks like this, that we override some of the functions that's used in here. Now, this can be a built-in bash function or a program that you need to install. Care can be both depending on the Linux distribution. And when you define the function exactly with the same name as here, then you can override its logic. So care normally here with parameters would call for this external URL, but we can override its behavior by just displaying the data from the file that we have prepared. Now, you need to export that function, and then when you do, and you run your function, so this function, this behavior will be replaced with that. So that's how the mock looks like in BATS. Now, we run this gets fed up to the test, and we make an assertion on the line that it should read to false. So let's first go in here. Let's source the script, and I will show you what it does exactly. And now when I run get task, the task ID for the test is 1, as you can see above. And as you can see, the output from the function basically should read to false. And this is what we are checking in here. Now, there's an important thing. If you're overwriting tools that kind of could potentially be used by BATS itself, so something that is available in BATS by default, can be that thing. It doesn't have to be, but can be that thing. Then you need to unset the mock at the end of the test. You don't have to do it if the function that you are overwriting, mocking, is your own. So if you wanted to mock that function, then you don't have to unset it, because each test is run within its own shell. But if you are overriding something that's potentially used by BATS, then you need to manually unset the mock. And that's how you mock in BATS. So for this positive case, we also have a negative case here. And then we also have an example of kind of integration test. So we also create a mock. So we are mocking this entire function so that it returns as status false. And then we are running the entire script in here and checking the assertions. So I call it integration test because it doesn't really test any individual function in isolation, but also it's not an end-to-end test because we mock some part of the entire script. Well, whether you treat it as integration test, well, I leave it up to you. So let's check if all our unit tests also with mocks run fine. They all do run fine with mocks. So we are good. Even we managed to, I need to say, comply with test pyramid because we have one end-to-end test, one IT, and 4 unit tests, which is good. So basically that concludes a very short introduction to BATS, which I think is great, and well, I encourage you to use it. But we've gone that far for one purpose. I wanted to show you how you can apply that BATS, maybe not apply, but how can you make sure that when in Azure pipelines you do write some custom logics in shell, in bash, then I will show you how you can test that at the same time, right? So for starters, we need to have some pipeline, the simplest one possible, and based on that repository that runs our script. So to run our script in Azure pipeline, we are using the predefined task shell script, and we are providing here script sh, so the location relative to the root and the arguments, right? So it's exactly as we are writing one file text. It's a very trivial example, obviously. But the things you can do in pipelines depend on your particular use case. I only want to show you how to approach that problem. So we have the simplest pipeline possible that runs logic from our script. Now, if you want to go to pipelines on Azure, let's create new pipeline. Let's create it from GitHub. You can use my repository if you are going to practice. You choose existing pipeline, and that's the pipeline without paths. And then hit run. Well, it takes a little while. Our pipeline is run. Well, we need to wait. Hopefully not too long. Okay, so pipeline is run. It's a simple pipeline. It just calls our script. And it's a success. Okay, that's great. Well, as you can see, it did exactly what I did on my local machine. Now, we have just used some custom logic in our Azure pipelines. So it's not a task that's predefined. Well, it is, but whatever is here, it's custom logic. So you have lots of these things. You incur that by putting something like this in your pipeline. Now, if you followed the steps or recommendation that I did, and you have prepared your script so it's testable, meaning its logic is split into individual functions, and then you follow all those good practices here, then it's testable. And if you add a script, then you should also have tests for it. And we have tests for it because the tests that we have concluded with are here. And if you want to add them to your pipeline, then that's basically how you do it. You install the paths, which basically is the script that I show you here. And as you can see, it's very handy because you can reuse it. We are installing the paths on the node where our pipeline gets executed because it's Ubuntu. And then if you want to execute your test, then you're just using the paths binary and you put the path here to your path script. So let's see how that looks like on Azure. We're adding new pipeline. This time we are choosing the pipeline with tests. We run. And then I now expect that first of all, I run my tests and then my real pipeline gets executed, right? Because tests is never the end result that I want. Okay, paths gets installed, tests are run, and my script is run. And see what I have. I have now continuous integration, even let's say continuous testing for my custom logic in my pipeline. As you can see, the tests have been successful, tests have been installed, successful, and my pipeline is also successful. So obviously, in your real production cases, you will probably want to decouple tests from actual pipeline, and you probably want to have some trigger for tests like pull request or commit or push or whatever. So you can do it. You can split that test logic into a separate CI, CT, CD pipeline, you name it, and then you are fully covered. Okay, you're using the custom logic in the pipelines, but then you have it tested, so you are good to go. And obviously, the approach that I'm showing here is kind of universal. So if you're using PowerShell, then there exists other test frameworks that you can apply exactly in the same manner. If you're using something that's not operating system shell, so for instance, script language like Python, Groovy, then they all possess their own frameworks. So we can do exactly the same stuff but with them, however, I still find it quite natural to script some logic in the shell of an operating system when we run tasks. So hopefully that was interesting for you. If that was interesting for you, then make sure to have a look at this GitHub repository. The URL is in here. There's also a Medium article showing step-by-step what I did just here in the written form. So for those of you who like to read, there is an article here. And also, if you like, then please connect with me on LinkedIn and we become colleagues. So thank you very much, and I see you next time around. Bye-bye.